Let's go. All right, we're back.
Are not obvious at all.
All right. In the first hour, we worked through quite a few problems, maybe like 6 pages of problems. We will copy and paste from here, and we will get to work. Does anybody have anywhere they actually got stuck as they were studying this weekend? You're here. I'm so glad you're here today.
Alarm didn't go off.
Okay. Anybody have any good? Nope. Anybody have any questions that they got stuck on as they were? If you do not have said review because you missed a lot of days, I have a copy here. I also have blank graph paper here. There's also a copy of the appendix or the second review somewhere floating around. We passed out last class. Does anybody have a stack of papers on their desk?
I have one.
That was on your desk already?
Mm-hmm.
Oh.
They'll give it to me.
Nope. Staying straight.
And it has soy sauce on it. So
I don't know where it went, but that's okay. Anybody have any questions that they worked on and got stuck on? Yes.
Number 9A.
Number 9. We are looking at finding zeros. That's a good thing to do.
I got like 2 of them, but like I don't know the last step. Like I found 2 of them.
Oh, you found 2 of them? So you do know the last step. But we're going to do it anyways and we're going to do it from the beginning. I promise you know the last step. It's a song.
Oh, okay.
Could you do that with what you have left down there at the bottom?
I thought that's what I was supposed to do, but I didn't remember it because that was...
100%. They don't have to be real. They're allowed to be imaginary. Let's find out together. All right, so the question was, hey, can I find all of the zeros of this function? Boop. And the answer is, of course you can. It's just one of the harder problems of this unit, I would say. I would say this is one of the more time-consuming problems of our unit. Not that each individual step is incredibly difficult, just that there's like 2 or 3 steps that you have to get through. So, if anybody remembers what the first step is, take that now. P over Q. P is... Yeah, see, I don't like how it's not in alphabetical order.
okay.
But it's fine. This is Q, and this is P, right? Or you could call it leading coefficient over the trailing constant. Either way, totally okay. So we're doing P divided by Q, which is equal to 7 divided by 5. But then what do we do with that information? It's not super normal. You factor it. So what are the factors of the top? And what are the factors at the bottom? There are twice as many as you would normally think, right? Plus or minus 1, plus or minus 7. Plus or minus 1, plus or minus 5. Then, well, wait, I'm gonna make a note because there's another question on the review, so we can do 2 birds, 1 stone. That's exactly the same, but we just almost finished it. This orange cloud is almost an answer. It's not a perfect answer, but it's almost an answer. The question that it's almost an answer to is, what are the possible rational zeros? What are you laughing about? Did I miss something?
No.
I spelled wrong?
Apparently you did. No.
Oh. I'm so confused.
I just feel like it's a waste of my voice.
No, I didn't acknowledge Isaac either. I just started writing. To be fair.
We wouldn't be here at this point.
Oh. We won. So the reason I said it's almost an answer is because it's not super perfectly formatted yet. You probably get 7 out of 10 points or 8 out of 10 points if you leave it there. But to super perfect format it, you know how we write this thing? Plus or minus 1, comma.
Do you have to do the set notation?
You don't have to add the set, but a lot of people do, and a lot of times you'll see it. But you don't have to in the answer because I've seen answers, particularly on our college algebra multiple choice exam where it wasn't set. But then our book puts it in set. So it's its own flavor of whatever you want to do. I'll go ahead and put it in set. Go ahead.
Okay.
Hit me with one more. 1 over 5. It was a fun one. You went all the way to the. Never mind. Anybody got another one? Nobody raises their hand no more.
Oh.
That's pretty funny. Remember raising your hand?
Oh my gosh.
We don't just be raising our hands in your face. You look right past them.
Just like
You should just let me answer.
Luke, give me one more. Nice. Max, give me one more. Fine. Yankee, give me one more. Don't trick him.
4.
Plus you're not Yankee, but yes. Is that it? That's not it. Oh wait, that is it.
You're going crazy.
You didn't put 1 over 7.
Yeah.
Oh, sorry.
Yeah.
Yeah.
I almost wrote it. I almost erased and started writing it, and then and then you got to use those. So that is the answer to possible rational zeros. There we go. Now we're about to do 2 review problems in 1. The real answer to this one, though, you take those numbers and what do you do with them? You synthetically divide them. Somebody's already done it, so give me the one to do, so I don't waste my time.
I think you use positive 1.
It's always going to be 1, maybe -1, but
I have a question.
yeah,
So on the test, it's either going to be positive, negative, 1 or 2?
usually.
Okay. So,
Every time I don't make the test. Every time I've seen it, 1, 2, 1, 2.
because I know, like...
I'm not saying it's going to be. I'm just saying start there and go to and see what happens. 1, 2, -1, -2.
So try the whole numbers first.
Yes. And try the low whole numbers first. Don't start in the middle. I'm telling you right now, every single one I've seen for the past 3 years have been 1 or 2. Now, that doesn't mean all of them are 1 or 2. It just means you can start with 1 and reduce it, and now it's easier.
I know, because of the C is gone.
All right, let's do it. 1, backward cell. 5. -46? This is the ugliest thing in the world. Drop it down. Someday you too will be super fast at synthetic dividing. Come to office hours and we can make that happen. Ready? 3, 2, 1, 5, -41, -41. Dang. Someday. 43? Positive? 43? -7? Look at that. That's my favorite thing in the world. We got a 0 in the bottom right. What does that mean? The remainder is 0. So that means that C is a
C.
0. C is the little thing inside it. From the book, they call it a C. If you just want to remember the little thing inside the square, fine. Which means X minus C. I'm going to call it C here. It is a factor, but then we can go up to the... I always do it down here because I can't see the thing. But then I'll go up here and say, oh, what does that actually mean? That means that X equals 1 is a 0. And X minus 1 is a factor 0. Boom. Look at that. We're not doing too bad. Not too bad, not too bad. And then we go X cubed, X squared, X. There's some plus signs in there. What was the next one? 7? Oh, that's ugly.
I think so, yeah.
That's a lot of work. All right, well, we're going to try out 7 because we cheated.
Yay.
I'm telling you these numbers are a little bigger than... But they're still good for you to practice. And there were only 8 total numbers to try. 5, -41, 43, -7. Drop it down. 35, -6, -42, +1, 7. Oh, egad, a woman in white. If you're like, well, I'll never be as fast as you at synthetic dividing.
Well,
Yes, you can.
you're not that fast.
Me first?
X minus 7, that's a factor. That's a 0. And we're going X squared and X. And now, wait, no way, Jose. I'm not doing the quadratic formula. I'm doing slide and divide. But you can't do, actually, let's just do the quadratic formula. I don't know. Which one is he? technically quadratic formula is the best because it just gives you a way out every time. You get to that little squared thing right there, your quadratic formula, you're done. You don't have to worry about what do I do next. Though if it were me doing this problem, I'd slide and divide because I feel like it's easier for my brain. But I'm going to quadratic formula this thing because that we know that always works every single time. So let's sing it together. 3, 2, 1. Negative.
X equals
Oh.
negative b plus or
Minus the square root of 3c.
all over 2.
Thank you. Was that so hard?
I mean, you started off.
I learned it that way. I learned negative b plus or minus square. Oh, there is
It's not
an
an equation. It's just
x is equal to negative b plus or minus square root of b squared minus 4ac over 2b. So then we plug and chug some numbers. X is equal to negative 6 plus or minus the square root of negative 6 squared minus 4, 5, 1. Right?
That's
All over 2, 5. Shh, 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 shh. What are you confused by?
What are we trying to find?
Zeros?
Oh, so we're doing it in like an easier way, not testing out all the possibles?
Yeah. I'm taking a little shortcut there.
up to the equation. Oh, wait, no, you did. You missed
What did I forget to do?
nothing. He thought you forgot something.
What did he think I forgot? The negative
You
sign?
forgot the 84. He did not. Yeah.
Wait, but if we wanted to, we can just again use the same one for the second time. We can use the same numbers for 7.
You can try them, but they're not going to give you another remainder of 0. No, you can't try them. They're possible. We do know some functions with multiple occurrences of 1, 0. Think about x squared. When it bounces off a multiplicity of 2. Sometimes it does happen that you use it twice. So we'll do it. Hang on, we got to get moving, y'all. 6 plus root of 36 minus 9 over 10. What?
4 times 5.
I was keeping you on your toes.
whatever.
And good job. Thanks for paying attention. I appreciate that. Some people weren't. Over here texting his mom.
No, I'm not the mom.
Oh, texting his girlfriend. Oh. Okay, I'll stop. 6 plus or minus. What? Don't laugh. 6 plus or minus. What's the root of 16? 4? And that's going to break down into 2 answers. 10 over 10 is. And 2 over 10 is. Pause. Were those allowed to be answers?
Yeah.
Look right there. 1. 1/5. So how many of the zeros have we gotten? We've got x equals 1. X equals 1/5. X equals. And there's a 4th one, right? It's a degree 4 thing. Shouldn't there be a 4th 0? Doesn't this have a degree of 4? What's the 4th 0? Oh, zoop. There's not. There's only 3 zeros. But one of them does double duty. Because it's got a multiplicity of 2. Because it occurred twice. Which means what happens at x equals 1? What happens right there? Bounce. And this is multiplicity of 1, because they only occur once. Pretty cool, pretty cool, pretty cool. Fully factored form. It doesn't ask us to do it, but you could. Yes, ma'am. Yes, sorry. Like the quadratic formula part. You're welcome. Also, it's all on YouTube. So you can just watch it, go slow, half speed, full, double speed, whatever floats your boat. I'll also post the PDF of all this stuff too right afterwards, where the normal lecture notes are. So if If you want to look at the PDF and just scroll through it and not watch a video, that's okay too.
Are we able to take the test at 9 a.m. on Friday?
Sure. I got no problem with that.
Okay, guys, we all show up.
No, that's not.
I'll skip a class to come take the test early.
Yeah, exactly.
I have another exam
I'll just come on Wednesday.
Yeah, that's how I feel like it actually is a lot of people have their classes. No, you can't come on Wednesday because I'm not going to have the right number of printouts or whatever.
I can't come on Wednesday?
No, I only have one testing room.
Wait, what if we have a test on Friday?
That doesn't matter. Dance is a good excuse because they had a note from the instructor or an email.
But I asked you last week and you said yeah.
I don't remember that, to be fair. Let's keep reviewing. We've only done one problem. We need to do more.
Question.
What?
What was the number?
Are you gonna show up at 7 a.m.?
No.
You gonna show up at 7 a.m.?
Shh.
No, it's not like finals.
Wait, how do we know that the X equals 1 and a multiplicity?
Good question. Say it.
Well, you see, no, because you see when you did synthetic division right there, you did one, and then boom.
You doing right there?
Yeah. Okay. And then let's go to the bottom, and then boom, you see it again. So that's twice it did.
Well, what about this one? How many? 1/5 only came up one time, right?
Yeah.
Where's the other one? Boom.
Wait, so if we're given like a multiplicity more than 2, we have to work our way down to the something that we're able to plug into.
You got to keep going all the way down until you get to your quadratic formula.
Okay.
You start at 7, you're going to synthetic to 6, synthetic to 5, synthetic to 4, synthetic to 3. Once you get to 3, you might be able to do grouping. Remember that ugly grouping thing from the test 1? If you can't do grouping, you go back synthetic to 2. Once you get to 2, you can always do the quadratic formula.
Okay.
So it's kind of like whittling your way down until you get to some other skills that you can use.
Okay.
Yes?
So if
No, you're good. Ask, you can frame it bad and we'll figure it out.
okay, so if the zeros, the possible rational zeros you came up with, like you put in the synthetic division, doesn't work.
That's a great question. Okay, boom. If they don't work, you've only learned one thing, and that is that there are, because the word possible is doing a lot of heavy lifting. So if you plug all 8, so right here there's actually 8, right? You plug all 8 in and none work. That means that there are no what? No rational. Yeah. Is there such a thing as a non-rational zero? I can think of a few. Let's think of like this parabola where it intersects root 2 and negative root 2. That's not ration means fraction. It's like almost that word. Ratio, fraction, the line underneath or whatever. That's not a fraction. That's an irrational number. That's a decimal that goes on forever. What is that parabola? That parabola is anybody good at math? I'm trying to write this parabola with a 0. Oh, we know the 0. X minus root 2 squared. Right? X squared minus 2. Is that right? Because the 0 is if you equal 0, you have to add 2 over, right? So x squared equals 2, and then you root it. Yep. Okay, look at that. Boom, 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 boom. That is a perfectly legal polynomial. F of x equals x squared minus 2. But you know what's wrong with the zeros? If you do synthetic division with plus or minus 1, plus or minus 2, and it's not going to give us what we want. It's not going to give us any because we know the two zeros are that and that. So there are no rational zeros. That doesn't mean there's no zeros. It just means that you have to go about a different way to do it. In that case, it would be the quadratic formula. Yes.
Thank you. Nah, it's still here. Okay, so you know how 1 is okay, so with 1 over 5, comma 7, comma 1, that would be a fine answer. Like we don't need to say, oh.
Sure, because of the word zeros. Yeah, that'd be fine.
Okay.
Chances are I'm going to go in and edit once I get it from somebody though. And I don't like the wording of this because it's so confusing. Like when Well, I'm going to give you blanks, right? And the blanks are, I'll go in and put blanks in there and say, hey, give me the x-intercept. Right? That's what it'll look like. And then you'll know exactly what format to put the answer in. So when it says zeros, it's really after x-intercepts, right? And I'll give you the format to put it in. So that would be like 1, 0, 1/5, 0, right? That's what a 0 is. And there'll be 4 of them. Yes. Instead of giving you a big blank and making you write the right format, I'll give you the format to put it in. I most often do that. Not every time. Sometimes I forget, but I like to do that. All right, let's keep going. We got any other questions that have been posing problems to people? Conundrums that have been confounding the class. 13A is a good problem. Do you mind if I do C? Because I did A in the first hour, and you can go and look at it, and that way we have 2 different versions, but it's pretty darn similar. All right, if you see one like this, it's actually pretty nice because it's on the not calculator section, which means you're not responsible for any of the crazy math. All you're responsible for is the method of doing it. So, any thoughts? There's actually 2 ways to do it, and I like both a lot. Log 6 is the way I would do it, the easiest way they would say. So you log 6, the whole side, not just a little bit of it. But, let's see if now what must we do because of math? Yes. Because of math, you must do it to the other side. And you're left with, scratch out, x minus 1 is equal to log 6 of 9.6 and plus 1 to both sides. And you're left with x equals, and because you're not responsible for the math, leave it alone. But wait. Well, it's no more. This is, let's put on our explorer shoes and not find the right answer to get a grade because I'm so worried about my grade shoes. What if your friend asks you this question, but they only have their iPhone? There's a problem, right? Your friend wants this answer. They're like, quick, I need this answer. This is going to help me know exactly how much money I have in my bank account. And they only have their iPhone. Fight.
You're gonna put something over something. You're gonna put log something over something.
You're going to put log something
Over log
over log something.
the top goes to, well, the bigger one goes to the top, and the smaller one goes to the
Boop goes up. Boop goes down. They go to where you would, if you had to pick where they would go, you'd be right. That's kind of the way I like to, they look like they're there, so put them there. Don't go flip-flop. So don't write. What? And then once you get that answer, you just add 1. That's just a different way to write the same answer. That formula is called the what's that formula called?
What is that with?
Starts with a C. C-O B. Concatenate. Concatenate a string. Now, you're doing a lot of concatenating strings and arrays and. Hey.
Something of base.
That's it. Base is it, and of is right.
Is it con?
What did you do to the base? Oh, close, actually. Not bad, but look at, what was the base here? What's the base here? Don't say there's not one.
There's not one.
10. So what is it called when something goes from something
Conversion.
to something else.
Change
of base. But conversion to base ain't the worst thing I've ever heard. You did convert the base. You converted it from base 6 to base 10. So if you were to write it on a...
Conversion of base.
Oh, is that yours? Who's trombone? Nice. That's awesome. I thought it was yours, and I was like, dude, sweet. All right, let's keep going. We got some time for 3 or 4 more for the break.
Let's do the more.
We're not really, or are you just saying that?
Yeah. Can we do like 12?
Okay, 1 and then 12b. Cool. Though I think for number 1, what does it say to do? I just cut it too short. What does 1 say to do? Someone's gonna have to tell me.
Min or.
Yeah, it can't be min and max. For these, I'm gonna make up a way harder one because these are insanely easy, and I think you'll be fine. So for D, you can give it a D. That way you can go practice these later, or just Google any parabola. Just like literally ChatGPT. Give me 100 parabolas. You can do it with it, right? Okay, so 14 x squared negative 14x. Ooh, I'm going to actually change it even crazier. Watch this. 7 plus 2x squared minus 14x. I've done 2 things that are really mean. What's the first thing I've done that's mean? It's out of order, and that's not nice because you might mess up ABC. And I've seen that happen a lot, actually. So, before you even start the prob, switch it back up, right? 2x squared plus 7. Okay? And then, what does it ask for? Oh, I don't know, because I just... Find the min or max. Well, hold up. I know that this is happy or sad. It's a happy what? It's got a name. It's a happy parabola, which means it's got itself a minimum. That's kind of nice to know. And then just solve for vertex, which we have a sweet formula for that called. Well, don't we have a? We have a letters that stand for the vertex first. Okay, but that's not helpful at all to us. But we have a formula for one of those letters. Negative b over 2a. And that means I have a formula for k based on that, which is... Good call. F of negative b over 2a. What? What? No, I heard you. So what is negative b over 2a? In this case, negative 14 over 2 times 2? Oh no. I'm so sorry. I made up a bad problem. So this is 14 over 4. 7 over 2. I didn't mean to. But we're doing it because what if it's on there? What if this is exactly what shows up? We can do hard things. It's good. What's the word? What's the last line? It might not be easy. Question. Good question. To compliment myself. What is that? What is that 7 over 2? It's got a really specific definition or name. It's not. I wish it was. What is that highlighted number actually? Isaac, don't do this. This is too important. Where'd it go? Where'd it go? No.
What are you looking for?
Oh, you used to have it. Did somebody take it? Oh, there it is. Haha.
No.
It is a phone copy. All right.
Can't even hang it up.
My phone doesn't
Can't even hang it up.
What?
My phone doesn't exist anymore.
It's okay.
That's so
I know, but it's
You can't even hang it up.
I know, but I'll find a way.
That's so. Oh my god. He just thinks it's.
What is that? That highlighted thing has a really good definition. What is that highlighted thing? While I look for
minimum.
No, it's not.
Or it's where the minimum occurs.
Okay, but what's x coordinate of what? That's a good definition. Shouldn't take a phone case to. It's the x coordinate of the vertex.
I refuse to believe we're not your favorite class.
You're allowed to believe whatever you want to believe. Anybody get the y coordinate? Because I don't want to do it. 2 times 49 over 4 minus 14 times 7 over 2 plus 7. No, you got it. Boom, boom, 2. 49 over 2 minus boom, boom, 7. 49. Oh, dang it. I shouldn't have done that. I should have left that alone. What's 7 times 14? Anybody good at math? Really?
Yeah.
Did you do that in your head that fast, or did you already have it?
I think I remember doing it.
Oh, that was fast. Plus,
You could be like him.
I think so. I believe. Very good. Then we got to do 49 minus 98 is negative 49. Plus 14 is negative 35? Okay. Dude, I actually have been looking for one on Amazon. No, but I want to have board, wireless speaker over there. Claps. Like for Max, I would have clapped, right? But then I also was thinking of something else that I really wanted to get, and I forgot. Toothpicks or popsicle sticks with names after test 2.
You gonna take something's name out.
Right. Our names are not even going to be in the
Oh, that's so funny. Or you just you don't even have to have it. You just grab anyone. They all have scribbles, and you just start lying. You don't even need it.
Lying.
Yeah. All right.
Think of the oh. I don't know.
What are we doing? What are we doing? Oh, someone said graphing.
Oh, yeah. 12B.
Add to the chaos and put random sticks where it's double it.
Oh yeah. Like you have 2 buckets, one with names and one with consequences or rewards. So like boom boom, 5 points on your next test. Boom boom.
The rewards are lies. It's just punishment.
What's up? No. To that one. This is all going to be online. This is all going to be online. You don't have to take a picture now.
Stop being nice. He's a liar. He lies to us.
All right, we're doing this one, and then we'll take a break. Though on the other side of the break, we probably should move. We've done a lot of parabolic stuff. We should probably move towards the slightly harder older brother of the parabola, namely the polynomial function. Right? I don't know. Just graph a polynomial. It's pretty hard. How do I copy this? Anybody know? Is it this button? Copy?
Well, we can do a different color for
No. This is a good one because there's some stuff that goes down here that's important. And I want to mention the failsafe for this problem and for all of these problems. There's a very important failsafe to keep in the back of your mind. What's the failsafe? What? Brute force? What does that mean? 0. 0, plug it in, dot. 1, plug it in, dot. 2, plug it in, dot. Try to recognize the shape and connect the lines, right? What? 12? 12? Are you looking for the graph? I just copied and pasted it off of Google. But if you want graph paper, I have it over here. I got you.
why I got a graph from. I got a graph right here. This is whatever they have.
All right. We just did this, so it should be pretty easy to find the vertex. We can go a little faster than last time and not answer every question. Which one do we want to do? A, B, C? Doesn't matter. B looks the toughest, just because it has the negative and the coefficient in front of the x squared. So negative 4 over 2 times 2. Oh, I just did that out of nowhere. Probably should have labeled it. H equals negative b over 2a equals negative 4 over 2 times 2 equals positive 1. I got. And k equals 2 times 1 squared minus 4 times 1 plus 6. So 2 minus 4 plus 6, so 2. Unless I messed up, don't trust me. Don't trust me. Don't just look at mine and copy me. Freaking do it yourself and then look at it and see if it works. Because I need someone to check me too. Though I think 1, 2 feels like a good vertex, yeah?
I got 4.
I have 4.
What, 2 minus that is negative 2 plus 6 is 4? Yeah, me too. 1 comma 4? Which way is this parabola facing? Up? So what do we know about it right away? This is not perfect, but guess what it doesn't have? Oh, it has a min. Cool. So the min is at 1 comma 4. No xi's. That's weird. Not a lot of times that happens, but good to know. Ooh, does it have an axis of symmetry or an AOS? As soon as you draw that vertex, you know what you're supposed to do? And by supposed to, I mean get to. Draw that axis down the middle. I guess now we just plug and chug, yeah? Plug in 2, what you get. So for 1, we got 4, and that was our vertex, namely. Shoop. Watch this. 1, 4. Vertex. I'm going to write this really cool. Okay, on the left side of the vertex, what do we got going on? Or the right, either way. Plug in a point and yell it at me. 0 is the easiest. 0 comma 6. You know what point I just found out because of that one? 2 comma 6. Because that's an axis of symmetry. What about 3 comma? Is it off the grid already? 2 times 9. Well, you don't know that. You're just guessing. No, do the math. Dang it. I don't think it is. It might be. I don't think it's off the grid. I think it's at the very top. Oh, it's 12? Are you sure? Did you do it on your paper or in your brain? It's 12. You plug in 3, you get 2 times 9 minus 4 times 3 plus 6. So 18 minus 12 is 6 plus 6 is 12. Good job, mathletes. So that's off the graph.
I knew it was off the
What'd you say? Indeed. Oh, we were going to say 3 comma 12. Also negative 1 comma 12. I think we're good to go. Oh, maybe we didn't label the y-intercept, and we probably should have. Well, what was the y-intercept here? 0 comma 6? Nope. I know we're flying. That's okay. I said I know we're flying through a lot of this, like going really, really fast. You can slow it down after the break and bless you, I think.
Thank you. Yeah, I was listening.
All right, take 7 minutes. Don't take the full 10. Take 7. Don't just take a mental break. Look through the review and the review appendix. for questions that we can work through and really fight through. Because it's really important that we study. I mean, I can say that until the cows come home, but it just is. Bye-bye. Start recording. We're doing x4 plus 2x squared plus 1 equals 0. Zoom in real big. Cut out this. Zoop. Can you see a nice neat parabola in there? I know we're rewinding, but hold on. Can you see a nice neat parabola somewhere inside of that ugliness? I see the C value. What's the C? Plus 1? I think I see the B. And what does that make the beginning? Okay. Now, so what does that make U? U is equal to x squared now. We're going to factor. Zoop, zoop. Are there any multiples of 1 that add up to give me 2? 1 times 1 equals 2? No. But 1 plus 1 equals what? No. I did both of those wrong. That's not good. Okay, so we get U plus 1. U plus 1 equals 0. They are the same. You're right. But U plus 1 equals 0 yields what is the U? No, just minus 1. Right? And over here, it's U equals negative 1. But U's not U. What is U? U is actually x squared. And how do you undo an x squared? Square root, square root. Square root, square root. Oh, buddy. So x equals plus or minus I. And the same thing over here. Why did I add the negative? Well, no, there's a real reason. Perhaps I should have done it in a different color. But where is the first time the square roots ever happened in this whole problem? Down at the bottom, right? And then I'm going to go back and look at their print. This is really the way you know whether you add the plus or the minus or not. It happened way late in the problem because I was doing some math that I was making up and I was moving stuff around the equal sign so I could get my x. I did a lot of the stuff there. So I've got to add the plus or the minus sign. They did, and then I go back and look at their print and say, did they ever print the square root symbol anywhere? No. When they type the square root symbol, they're telling you, hey, I already know it's positive. I'm writing positive in front of it. Excuse me. It's essentially like this. You can think of it like this. When you're the one introducing it, you don't know what it was. But when you're taking it across the equal sign, you don't know what it was. You got to be careful. But if I was writing a problem for you and I was like 2 plus the square root of x plus 1. You know what sign that square root gets? Positive. I told you it was positive. I put one right in front of it. What about minus? It's getting a minus sign, right? What I'm not allowed to do is that. Well, that's a times. Dang it. That. If I went like that, you'd be like, I don't know what's going on here. When you're typing a problem, you have to give that symbol. If you're the first person to introduce the thing somewhere in the middle, you got to throw that plus or minus down. That's why the quadratic formula adds a plus to minus, because we just introduced it to a problem that didn't start with it. Yeah.
I was going to ask for a problem.
Yep, let's do it. You were going to ask for a problem?
I was going to ask what that was.
It was 14B.
We redid B because it was fun.
Oh, no.
But you got a problem as well? Go for it. Yeah, it's okay. We can do number 1. No, I'm just kidding. We already did number 1.
Number 3.
Number 3. You like being for real, or you like being funny?
I'm for real.
Do you? I grade your test, man. I don't think you are. Well, then talk me through it. So, or talk everybody through it, not just me. Talk us through what you would do if you were on number 3, and I said all the marbles for this. 100 in the whole class if you can answer this right. What would you do? Talking to Max.
Are you talking to me?
Yep, 100%. Like, I'll give you 100 in class right now if you can get this right. What would you do?
F0.
I mean, sure, but what does that mean to do in real people words, not in math words?
Replace all the X's with zeros.
Plug, yep. Replace all the X's with zeros, just fine. Mm-hmm. Yeah, F of 0. So, zoop. What is F of 0? 0 plus 1 over 0 squared plus 2.0 plus 1. 1 over 1. Wow. Yeah, I need to get it. That would be so fun. I don't have an iPad. It's a computer.
Is it?
Yeah.
You do it on your computer too.
There is an app on the computer called WavePad, and it's all the keys become the thing. So,
I just kind of go to a website and click on play.
but then you would be able to see that website.
And then you give everybody else the power to do it.
That'd be pretty funny. All right, let's keep going. Thank you, Max. I appreciate you asking. Anybody else willing to contribute a question to the class? 50? Don't know where I got 50 from. So I didn't think we had that many problems. Oh, we did say that. I forgot. Sorry. Thank you for bringing us back. We got a graph irrational. I did B in the last class. You mind if we do C? C or A. Eventually we'll get them all. We'll probably do the other one on Wednesday, at least. I'll zoom up to that other one if you want to take a picture of it, as some of you are inclined to do. Oh, I got to go copy a graph anyway. So we did B in the last class. There's a video. It's already posted on YouTube. Smash that like button.
Like and subscribe.
Subscribe. I really would like, but here was us graphing it. We got a few things done. We got the y-intercept, the x-intercept, the vertical asymptote, and the horizontal asymptote. We made a nice little t-chart to slowly do it, which we're about to do with the other problem. And then when we got stuck and we didn't know what to do, we just plugged and chugged some points. And it looked a little like that. It ended up being off the graph. C'est la vie. It won't be on the test. It'll be on the graph. Let's see. Let me copy this, though. Oh, man. Ow. Boop. All right. We're throwing down with C. So there are, again, 4 things to be found. One is clearly the easiest. I think it's the easiest. Anybody know what the easiest thing to find is? I think it's the y-intercept. I think the y-intercept's the easiest to find. In 3 words, how do you find a y-intercept? I got you. I've changed you. Plug in 0. I've changed you all. Not set x equal to 0. Though it's the same thing. And so if we were to plug in 0, then we would see that f of 0 is equal to, and we're doing this one, don't forget. Oh, are you doing A? 1 over negative 1, which is just negative 1. So the y-intercept is what point? Let's go plot it in red to match the color. 0, negative 1. All right? That kind of informs the second thing because it sounds pretty similar. Also, if you need graph paper, shoo-ba-doo. A lot of graph paper right here. For those of you that are just letting me do math. I know how to do math, dude. I already know how to do this. X-intercept. How do we find x-intercept in 4 words? Close. There's one word missing. Set. So I didn't hear it. No, you're missing one bit important word. Set top equal to 0. No, it's the same thing. You would just multiply the bottom across, and you know what 0 times anything is? 0. I'm just saving you a little bit of writing by saying that. Set equal to 0 is the same thing. So set top equal to 0. And we're doing x plus 1, right? Which means that x equals -1. So what is the x-intercept? What's our x-intercept then? Go right down there and graph an x-intercept, -1, 0. All right, let's do a V8 or a vertical asymptote in green. These all flow out of each other. This is great. If you start with the easy one, you do y-intercept. Y-intercept, plug in 0, not too bad. Oh, intercept, x-intercept. That's the next one. And then x-intercept, oh, we set the top equal to 0. You know what else we could set equal to 0? The bottom equal to 0. And you know what that yields us? A vertical asymptote. X minus 1 equals 0. That means that x equals 1. And that is a vertically dashed line. Don't do that. Just trying to delete my graph. And if there's a vertical asymptote, that means there's a horizontal asymptote. And for said horizontal asymptote, we look at the leading coefficients and their degrees. So we've got x divided by x, which is equal to 1 over 1, which means that the horizontal asymptote is y equals 1. Remember, but there were 3 types. Top, bigger, top degree bigger, goes up forever. Same degree, it's A over B. Bottom degree bigger, it's y equals 0. Sorry for talking so fast, but felt like that recall was important. And so we got ourselves a horizontal asymptote of y equals 1. Oh, shoot. Look at that graph. That kind of checks out. Connect the dots. Anybody got any idea which way this is going? Shoop. Probably like that. Shooby-dooby-doop. Probably like that. And where else does this graph have to go? You want to plug and chug a point or two? Though we think we know where they are? You're pretty sure they're in those perfect spots, right? But perhaps we plug and chug 2 just to see. 2 yields us 3 over 1, which is 3. And 3 yields us 4 over 2, which is 2. Nope, that's wrong. Boop, boop, boop. We plugged and chugged a few points just to check. We got all our intercepts. We got our horizontal asymptote. We got our vertical asymptote. What'd you say? All right, let's find some stuff. Anybody got? Anybody got the harder version or the test 2, the appendix?
You can have it.
I can have it.
You said you could buy a copy of this.
No, I have it on here. I just didn't know if I handed it out the other day. I'm guessing yes because I see it there and I see it there. Okay, cool. I'm not telling you to get it out. I was just going to say there are no questions on it, so that's why I was wondering. Stop laughing. It's not comedy class.
Will it be a word probably like
It's probably going to be a lot like that one. I like that question a lot. No, that question's so fun because it's the only real one so far. Wait, okay, which one? I don't even know what you're talking about. Yeah, that question rocks, actually. You're crazy. Is he throwing a rock? Is that funny? Or is it a football? What is the problem about?
He jumped off the cliff.
Oh. Oh.
You jumped?
Thanks to,
Jason jumped off a cliff.
into water, I hope?
Nah.
Does it say into water?
It says onto bedrock.
Really dark.
No comment. No comment.
It's really fun.
Oh, no, he was like, oh, I said, all right, Jesus is the one.
Get me demonetized on YouTube. I don't make any money. All right, Jason's hanging out with some friends, and his friends are like, "Hey, we're gonna jump off a cliff. You should do it too. Don't follow peer pressure." We got ourselves a parabola, right? Let's before we even look at the questions, they actually, dang it, you're all cheating.
What are you talking about?
I can't do this because you have the paper in front of you. But I think it's actually a whole lot more fun to do this. What questions? This is just one little fun game I like to play when I'm studying. Is to take the thing that they give you, the only thing that they give you, right? And ask myself, what are all the things I could know about it? Not that they ask me to find. What's everything in the world? Sorry, church.
What starts with the C's for
Either way. Text message, phone call, somebody comes up, we need a group meeting attention. Okay, sorry. So what are some things we could find? We don't know what they're asking for. I'm not going to draw a picture. Usually I start this part by drawing a picture and all that stuff. Not going to do that this time. I'm going to find out all the things I know about that equation. What? No. We don't know anything except for this. Shh. This is fun. This is really fun. We don't know anything except for this. What? Yes. No.
The what? What did you say?
The y-intercept is... Okay, we got one thing. This is a fun game we're playing. Do we know anything else that we could find?
the max
How?
find the
Negative h equals,
negative
which is negative over 2 times negative 16, right? So negative 16 over negative 32. So 1/2 is the what? 1/2 doesn't make sense as a max height.
Oh, you have to plug it
You got to plug it in. 1/2 is actually what? The time when the ball's at the top. Oh no, we have to plug in 1/2.
Oh, did you make this? You did.
Good chance I just made these up. That's okay. Let's see. H of H. Ooh, that's ugly, but it is what it is because see how it's H of T, and we did H for the vertex. Sorry about that. Let's do capital H. Capital H for the height, lowercase h for the vertex. Look at that. We fixed the problem. So what do we got? We got negative 16 times 1/2 squared plus 16 times 1/2 plus 480. Please. Negative 16 over 4 plus 16 over 2 plus 480. Feels like that 480 is going to do a whole lot of work here compared to 4. This one's just -4, right? Oh, wait. These are nice numbers. Oh, thank goodness. I probably didn't make this up. These are actually work out to be pretty nice, even though there was a fraction in there. 8 and 480. So we got 484. No? Yeah. Yeah, it is. As long as you went back and multiplied it at the end? No. If you were to factor 16 out first and do the inside function, negative b over 2a, just don't forget you got a 16 hanging out here that you need to multiply. So, no, it wouldn't. Because when you factor something out, you're not getting rid of it. You're just holding it out front for a minute. There's the difference between factoring it out. I don't want to lose this. It's hard to explain.
Would the factored out 16 become one of your intercepts?
No, because it doesn't have an x with it. But what I want to be really careful with is when you're solving for intercepts, get rid of that 16. It don't matter. Because you divide by 16, kills it. Divide by 16, 0, 0, stays the same. When you're dealing with the equation as a function form, you can't just divide by it and get rid of it, right? So there's this hesitation where it's like, wait, sometimes we just divide and get rid of it and it doesn't matter. And sometimes you're like, no, you can't do that. You can't just get rid of this thing randomly. It's because a lot of times in Algebra 1, the teacher only cared about you setting equal to 0 and solving and not learning, right? And that's where we get this whole just divide by 0 or division cancels a bunch of stuff out. And it's not canceling anything out. It's turning it all into ones. But it's important. That dividing by 16 is a really important thing. And I didn't do it for a reason because I think it's easier to see the whole problem as a whole without doing it. But it's a totally valid way to do it. No. We don't have anything to scroll over to. This is everything. Remember, we're just doing an exploratory problem here. Any other things that can be found? What? B?
The answer for B.
I've been doing that.
We found something? Crazy. That's going to keep happening. Ooh, I know what we haven't found yet. Anybody else know what we haven't found yet? The zeros. Isn't that fun? You know how to find zeros? How? Set the whole dang thing equal to 0.
That's technology. You can do better.
Now we get to do what Aaron was talking about. Divide by 16. Divide the whole thing by negative 16, perhaps. Lesson of my life in this class. Can that 16 just get taken to all of these things? Yes. You know what it can't do? Only take out 2 of them. That's not allowed. And it certainly can't only take out 1 of them. That would be like you saying 16x plus 2x plus 1, and you're like, you know what I want to do? Just get the 16 to the middle and leave everything else alone.
As you should.
No, nobody in the world would do that, right? That's not the world we live in. But sometimes it's tempting to be like, 16, 16, go away, when nothing else matches. And it's just not allowed. Right. What the heck? So we're left with... Power through. Let's power through. T squared plus... Nope. Minus T plus 30? Minus 30. And does 30 break down nice and neatly? Should. Negative 6 and 5. And so T minus 6, T plus 5. Which means T equals 6 and negative 5. So if I were going to graph this whole thing, see? I'd probably go negative 5. Positive 6. What? Yeah, I did. Like 74. 480. Wait, well, the y-intercept was 480, right? Hey, whoa, stop. We're in the middle of a graphing problem. So we got negative 5, 0, right? 6, 0, right? What is the y-intercept here? 0, 480? What is the max height? Slash, where does it occur? And it occurs at 1/2.
Oh, yeah.
He did jump. That's really tall, right? Wait.
He must have got like that.
Oh, yeah.
What?
He jumped on the trampoline.
No, yeah.
Well, then what? But 480 is the cliff feet, head height. Maybe. Who knows? Yeah, fine. Well, then he's really short.
Yeah.
If it is the max height of his head and the feet, then he's like really short and not a good jumper.
Maybe he's just having things with gravity.
Hang on, what were we? 1/2, 484?
Yeah, that'd be bored.
I have a question, though. This is really, really important, and the whole purpose of our quadratic lab. What is this graph showing us?
The trajectory of his fall.
No. This was... Wait, what did you say?
The trajectory of his fall.
No. This was the whole purpose of our lab. If you think back to the quadratic lab we did, what was the only difference between that and the lab before? You had to do what? You had to do, on the quadratic throwing a football lab or whatever you threw outside, you had to do 2 different ones, right? Which one is this?
Oh, this is the height and time.
This is the height and time. So that's not what he flew. This is a visualization of how tall he was over time. And so now we can, with that in mind, you can answer some of these questions and say, how long did it take him to reach his max height? 1/2 of a second, right? What was the highest point Jason reached? And Jason hit the water after how many seconds? And we did all of that without knowing the questions. But it's just because it's all the same stuff. But
Does the guy in this equation die? Isn't that like concrete?
No, he hit the water. Like the water
Well, it
was
depends on if he landed right.
yo, I don't think we're realizing how much 400 feet is.
He's going back in first.
He broke some on your head. He broke a leg. Or his
Wait,
arm or something.
y'all, I'm not thinking. What? Tallest water jump. The tallest water jump in history is 193. What is this problem?
That man was trying to get over here.
Trying to go. You know what he was doing.
Oh my god.
Holy moly! No way! Ain't no way!
Are you watching a video?
Yeah. It's taller than the Leaning Tower of Pisa. That jump is taller than the... Not this jump. This jump's twice that tall. That's crazy. Alright, I gotta check roll. 3 minutes.